Good afternoon, my dear students. Hope that your first session was gone very well. Today I am going to start a new topic which is very interesting, and its utility is in a wide range in different field like engineering or in commerce, in economics. So this particular chapter is its utility is very wide. So name of the chapter is Determinant, and I just want to go and explain few basic idea before starting the topic. You know that simultaneous linear equation in two variable you got in class 10 or 9, I think. And suppose that there are two simultaneous linear equation. One is a1x plus b1y equal to c1. Another is a2x plus b2y equal to c2. This system of equation can be written in matrix form as. How you can write in matrix form? It's very interesting. The matrix form is, you see, the coefficient of x and y is written in the form of square matrix, and the solution of the simultaneous equations x and y, value of x and y, that are represented by a column matrix, and the right hand side constant is represented by the column matrix again. And this is written in Ax is equal to b, and A is called the coefficient matrix, this one, X is the column matrix, and B is this one. How you get from, how to relate this to your simultaneous linear equation? See, suppose this is your equation, this is your matrix A1. Matrix form system of equation can be written in matrix form as this is A2 B2, this is the square matrix, this is the column matrix XY, and this is, all right hand side is also a column matrix. Now if you use the matrix multiplication, you get A1x plus b1y, first row first column. There is no other column, so you cannot move ahead right hand side. Next, with starting with second row first column, a2x plus b2y you will get this matrix. So matrix multiplication is like that. First row first column, a1x plus b1y, there is no other column, so no need to go in the right, another column created. So first column, first row first column is complete. Then you start with second row second column, a2x plus b2y. So finally this is the product of these two matrices equal to c1 c2. This is the column matrix. Now this is also a column matrix of order 1 by, this is how many rows? There are 2 rows, and there are 2 rows also, 2 rows 1 column, 2 rows 1 column. So equality of matrices, you can say a1x plus b1y equal to c1, a2x plus b2y equal to c2. Ultimately you get your original, that is the simultaneous linear equation. So this simultaneous linear equation can be written in this matrix form, and this matrix form is written as x is equal to b, and this A is called coefficient matrix, which is a square matrix, x is called solution matrix, and b is just a normal column matrix. So every simultaneous linear equation in two variable, pair of simultaneous, or that is you may get more than 1, 2 or 3 simultaneous linear equation can be expressed in the matrix form like Ax is equal to what? B. Now come to a very interesting concept you got in school. The simultaneous linear equation in two variable, this one and that one, have a unique solution when a1 by a2 not equal to b1 by b2. You got in school, and if you cross multiply, you get a1 b2 is not equal to a2 b1, and then finally you get a1 b2 minus a2 b1 not equal to 0. This a1 b2 and a2 b1 is what? It is a number. Since a1 b1 a2 b2 are coefficient of x and y, this coefficient may be real or may be complex, and ultimately the product, this particular expression representing a number, it may be real or may be complex. This quantity can be expressed in the form, a new introduction of expression of this particular quantity in two vertical lines in terms of rows and in terms of what? Columns. This is the first row, this is the second row, this is the first column, this is the second column. And that particular expression, this particular expression is a number which is real or complex according to the value of a1 b1 or a2 b2. So if a1 b1 a2 b2 are real numbers, then it becomes a real number. If any one of these are complex number, or then it will maybe a complex number. Okay, this particular expression under two vertical lines in terms of rows and columns is newly introduced as symbolized as a particular symbol that is called delta, and this particular delta is called determinant. That means delta equal to this is delta equal to this. Okay, delta equal to a1 b1 a2 b2. Okay, or since this particular expression a1 b1 a2 b2 is associated to this square matrix, and since it is denoted by, this square matrix is denoted by capital A, therefore this particular expression delta can be written as a what? Determinant of A. This particular expression is associated with a square matrix this, which is denoted by A, and therefore this delta is expressed as determinant of A. So ultimately determinant of A equal to what? In this case a1 b2 minus a2 b1. How you get? Expanding line that a1 b2 minus a2 b1, and this is a real number or complex. So this is a number. Ultimately determinant, what actually determinant is? Determinant is associated with a square matrix. Determinant is associated with a square matrix. Determinant is a number which may be real or complex, or complex associated to a square matrix A. Finally, we can say determinant is a number, real or complex, is associated with a square matrix. If you suppose that A is a matrix of 3 by 3, then is determinant denoted by this symbol, and it is denoted by delta. It is a number, but it is not a number. It is just an arrangement, and this is a number. You can expand it and you can get a value, and which is real or maybe complex, depending on the entries in the matrix. So finally, if we suppose that M is the set of all square matrices, there are many square matrices of any order, any 2, 3, 4, whatever be. So if I consider M is the set of all square matrices and K is the set of numbers, maybe real or maybe complex, then you see we can relate. You can create a relation. We can create a relation from M to K. Suppose the element of M are square matrix A1, A2, dot dot dot, and the element of K are numbers, maybe complex, maybe real. These are denoted by delta 1, delta 2, delta 3, dot dot dot. Here you see every square matrix is associated with a number, and that number belongs to what? K. Similarly, every element in M is somehow related to some element of what? K. And that particular relation is what? A function, because every square matrix is uniquely related to some number in K, and that number is denoted by determinant of A. This number is denoted by FA1, image of A1 under F is denoted by FA1, and FA1 is equal to delta 1, and delta 1 is nothing but what? Determinant of A1. That means every square matrix is uniquely associated with a real number or a complex number, and that number is called determinant. So finally we conclude that what is determinant? Determinant is nothing but a real or complex number which is associated with a square matrix. So every square matrix is associated with a number, maybe real or maybe complex, is called determinant of that square matrix. So I hope I can make you understand this particular concept, what actually determinant is. In the next class, I will discuss about the properties of determinant and how to expand a determinant of third order. The second order determinant is very simple. Just how to expand determinant of second order. It will be a second order determinant, just expanding like A1 B2 minus A2 B1. But when a determinant is expanded for third order, so what is the rule? I will discuss it in the next class. So go through my videos 2-3 times and try to clear your concept, relate with the textbook, and I also suggest you have to go all the properties, try to understand, and I will come back with my points and try to clear your concept. Thank you very much.